Welcome to this webinar on the data market Austria. So this is today a tutorial for the data ingestion pipeline. But before we start and I hand over to Sophia and Christoph, I want to say some words about the status of the DMA project. The DMA project is now in its third year, and in its finishing year of the research project, a follow-up will come. And we have done those 3 years a lot of requirements elicitation, a lot of basic building blocks provision. Means we have identified the functions for a working data market Austria and tried to get modules working which serve those functions, which are search and recommendation, which are contracting, which are provision for the data and for services, which is blockchain mechanics in the behind, and also a data provision from bigger repositories. These are those building blocks which we have coupled in a portal, which is now to be finished. And in this finishing period, we also have invited via the FFG other projects to join us and make their pilot trials here. I think some of you are from those pilot projects, and we can talk later on. Yeah, this is the status. So we are in the finishing phase and want to get things into the world. For sure, it's a better status suite we are providing now. But I think we have done a lot of work which is useful for you all in the data providing and data trading scene. Yes, I think this is the first introduction, something for the organization. Please, if you have questions, I'm sure you have questions during this presentation, put them into the chat. There's a chat window in this control panel of GoToWebinar. And I will moderate a question and answer session after the presentation. The presentation is now done by Sophie Herrmann and Christoph Reimer of the Earth Observation Data Center, which is a very active partner in the DMA consortia. Yes, I hand over to Sophie and Herrmann. The floor is yours.
Also, good morning from my side. As we already heard, my name is Sophie Herrmann. And together with my colleague Christoph Reimer at EUDC, we developed the workflow to publish UDC data into the DMA environment. And today I will talk about exactly this workflow. Sorry? Okay. The general goal is to make data available within DMA. In order to do this, external metadata, so for instance, UDC metadata, has to get into the DMA central node. Regarding the wording, in the following, external infrastructure, like for instance UDCs, will be called external node, and DMA infrastructure will be referred to a central node. But first, some words regarding the structure. I will start with a short description what the dynamic data provider is, so whether the following workflow could be used by a specific data provider. Second, I will give some details about the interface between the external and the central node. So what is the final structure an external node has to provide so metadata can be inserted into the DMA catalog. As a third and main point, I will explain EUDC's proposed solution. So basically our workflow, the reasons why we implemented it this way. Yeah, I will then give an example how the whole process is running on our infrastructure, and also what needs to be changed by other data providers to use our setup. Okay, let's start. Within DMA, two general types of data providers were identified: static and dynamic ones. A static data provider hosts a small amount of data, meaning, for example, only 10 or 100 files. And also the file size of the single files is not too big. So it means there's no problem to transfer data. In addition, as the name already indicates, data is static over time, so no regular updates are expected. Last, the data is licensed to be hosted on a remote server, so no proprietary data. On the other hand, dynamic data providers can be characterized by the following points. A big amount of data is hosted, for example, up to 1 million files, and also the size of each of those files can be quite big. So that means transferring data is not a real possibility. Data is dynamic over time, so regular updates, meaning adding new data, changing existing data, are planned. And finally, a self-hosted metadata catalog has to be available. This means the single resources already have some metadata, and this metadata can be accessed in an organized manner. I think this last point is really important for the following slide, so just keep it in mind. If the points of a static provider best describe your setup, take a look into Conduit. I provided the links over on this right side down here. This is also a package developed within the DMA project and provides a nice web interface to create metadata and then to publish it. This presentation will focus on dynamic data providers, so how a big amount of dynamic data can be ingested into the DMA environment. Knowing what kind of data provider you are, we can take a look at the interface. So basically the layer between the external node and the central node. Within DMA, the so-called resource sync protocol is used to synchronize the DMA catalog with external data archives. So for instance, EODCs. Resource sync is a standardized framework to do exactly this synchronization between a source and the destination. The protocol supports different capabilities, but the most important one here is how changes can be communicated. So for example, the creation, the update, or the deletion of a dataset resource. Yes. In more detail, resource sync defines a hierarchy of XML files, where each one links to the lower and the upper level. Each of these yellow, blue, and also green shapes represent a well-defined XML file. The yellow ones use the sitemap, and the blue ones the URL set document format. To the green ones, I'm going to come in a bit. All of them have predefined mandatory tags which have to be used in a given structure, so well-defined document formats. As I also already mentioned, the protocol supports different capabilities, which we can see here. So for instance, one to synchronize fixed static data resources, and the one most important here to describe changes incrementally. Focusing more on the parts which are needed here. As I just mentioned, resource sync defines a set of hierarchically structured XML files. The XML files here in this upper part, which are called service description, describe the service itself. So most important, the available capabilities are described. As we saw before, the resource sync supports various capabilities, but in our case, the only supported capability will be the one to describe changes. And all of them link to the next level, as already mentioned. The middle part describes available changes. in the format of a change list index and a change list. The change list index lists all available change lists, and then a change list again points to the available resources. Resources in this sense are always metadata. The lowest part describes the metadata of the single resources. ResourceSync does not define how this metadata has to be structured, but to still get a homogeneous output within the DMA project, the so-called DMA-DCAT XML format was defined. These DMA-DCAT formats obviously need to include the metadata of the external resource, but they also have to include so-called DMA asset IDs. A DMA asset ID is basically a unique identifier within DMA. Asset IDs can come from the DMA blockchain and are needed to create an offer. And again, offers are needed to sell a resource within DMA. So without an asset ID, resources cannot be sold. That's within the DMA project also a really important point. To summarize this first part a bit, dynamic data providers need to implement the ResourceSync interface. Therefore, a service description, change description, and resource metadata in DMA-DCAT format need to be provided within the web server. To achieve this, metadata of the external resources and DMA asset IDs are required. At this point, I want to enforce that those are the requirements. Everything I will present from now should be seen as an example implementation fitting EUDC needs. The whole code I will present is open source and available and can be modified for other data providers' needs. Still, if you want, you can also write your completely different code. Just keep in mind to fulfill those requirements. Having this said, I will start with our EUDC thoughts, how to handle all these needed XML files. The first option is to create and then store them. The problem with this solution is that this requires disk space, and in our case, where we already store metadata, everything will be duplicated. The advantage of this solution is that whenever one of those XML files is requested, it can directly be returned. The second option is to create all the files in an on-the-fly manner, meaning only when they are requested. The advantage here is that basically no storage is needed, but when requested, the file first needs to be created before it can be returned. At EUDC, we decided to do kind of a mixture, still focusing more on the fly idea, but storing some especially, let's call them slow parts. So what does this mean in detail? As I think this is the most interesting and maybe also most complex part, I will explain this idea on the example of how these DMA-DCAT files can be retrieved in an on-the-fly manner. Okay, when a resource is requested, first the external metadata needs to be retrieved in the external metadata structure. At EUDC, we use a OGC standard compliant CSW server to provide this metadata. Therefore, the first step is to query and get back our metadata from the CSW server. In the second step, the external metadata format needs to be transformed to the DMA-DCAT format. To do this, the so-called metadata mapper was developed. This is a simple web server written in Java, which runs inside a Docker container. To use it, some preparation steps are needed. First, a mapping has to be created between the external metadata and the DMA-DCAT format. This can be done from a web interface, the so-called mapping builder. The mapping builder returns a mapping, which as a second step needs to be inserted into your metadata mapper, so into this Java web server. And third, pass any of your metadata files and get the DMA-DCAT file back. Obviously, the first two steps only need to be done once, and then reuse this mapping as many times as you want. Okay, in the general resource provision, at this point, we have a DMA-DCAT file. The third and final step is to add a DMA asset ID. Getting an asset ID from the blockchain can be slow. So therefore, we decided to not do this in an on-the-fly manner, but rather retrieve them on a regular basis and store them in a database. And when needed, we can get this asset ID from the database and put it inside our DMA-DCAT file. At this point, the final DMA-DCAT resource metadata can be returned. So we are here, the last step. This DMA-DCAT file is then processed by services running on the central node, which insert your metadata into the DMA catalog. And well, that's it. As I mentioned earlier, only providing DMA-DCAT resource metadata files is not enough, but rather the whole resourcing protocol needs to be implemented. Therefore, let's take a look at the complete setup we developed at the UDC, which looks like that. In general, two main components were developed: the external node endpoint and the asset retrieval service. The external node endpoint is a web server that implements the resourcing protocol. Each component here, so each of these boxes, returns an XML file in the defined structure. The source description and capability list return static XML files. The change list index and the change list use the asset DB, which I already showed on the last slide, to retrieve information. In our setup, we said we will create one change list per day. So the change list index gets all available days and creates a list entry with all the change lists, one per day. And a single change list then gets all the available resources of a single day and creates entries for those resources. And the last box down here, I already discussed in more detail. It's the retrieving the DMA-DCAT file. The second component, the asset retrieval, implements two main services: one to get asset IDs from the blockchain and store them into the asset DB, and the other one to create an offer for a resource. As I mentioned before, to sell your resources, they need an asset ID and an offer has to be created, which, among other things, adds a license to your resource. For completeness reasons, also a third package, the asset DB, was developed. This package defines the database structure and some base functionalities. For simplicity of the setup, Docker files for both packages are provided, and also a Docker Compose file is available, which sets up all of the components basically in one command. So if you're interested, have a look at the external node setup. Next, a small example how we at UDC use these packages. First, the asset retrieval service. We set up a cron job which runs every day at midnight. This job triggers the add assets. So all identifiers from the day before are added into the asset DB, and also an DMA asset ID is added. After this, the second job is invoked, which inserts yesterday's date to say, okay, all changes from yesterday are in the database, so we can create a change list for this day. As an example, I added here our two cronjob commands. The commands can also be found in the README of the package, so if you want to copy them, there they are in plain text. Regarding the external node endpoint, we simply run our web server, meaning as long as our Docker containers are up and running, everything is fine, so we don't really need to do anything there. To see the actual output of the external node endpoint, I put some of them here together on this slide. So the source description, the capability list, the change list index, the part of a change list actually, and also part of a resource metadata. Just to mention it, the used web server was running on my local machine, so don't be confused by the URLs. And also to mention it here, it's also quite obvious that all these single XML files always link to the next. So here the capability list is linked, here the change list index is linked, and also the other way, capability list for going back up again. EODC's official external node input is accessible over the node.dma.eodc.eu. And finally, maybe one of the most interesting parts of this presentation, if you're a dynamic data provider and want to use our packages, what needs to be modified? I tried to keep it as simple as possible. First, everything that depends on the external metadata needs to be changed. I said EODC uses a CSW server, so depending what you use, modifications need to be done. So here. In more detail, one function in the resource and also one function in the add assets needs to be changed. In both cases, the function should basically return your external metadata. Second, obviously some configurations need to be adopted. In the configuration, the location of the other packages has to be specified. And additionally, any parameters needed to access your external metadata. So again, maybe a URL, maybe some access credentials, depends on your setup. Access credentials are also needed to connect to DMA components. So make sure you have a user and a client registered in the CAS in the DMA user management tool. And finally, when creating an offer to sell your resources, you need to choose a license. This license first needs to be created in agreed. And then I added an option in the asset retrieval service that you can set the default license. So add the hash of your preferred default license also to the config file. But sample config files are provided, so I hope everything in there makes it a bit more clear. Having changed the two functions and the configuration options, just run the Docker Compose and everything should kind of run out of the box. Yeah, that was mainly it. Summarizing the content of the presentation, I first talked about the types of data providers and said that the presented workflow is meant for data providers hosting a lot of dynamic data and also their own metadata infrastructure. As a second point, I explained the interface between an external and the central node, so the resourcing framework, with its hierarchical layers of XML files. Then I started talking a bit about EODC thoughts. I stated that we did not want to duplicate our metadata and therefore developed an on-the-fly workflow with two main components, the external node endpoint, web server, and the asset retrieval service. And finally, I gave an example how this workflow is running at EODC and showed that only two functions and some configuration options have to be modified. Sorry. I hope. Okay, great. Yeah, that only two functions and some configuration options have to be modified to run a similar workflow on a different infrastructure. With this, I hope I could give an overview of what needs to be done to get your metadata to a DMA and also how this could be done. Thank you. If you have any questions, please ask them now or send me a mail. I'm happy to answer them. Thank you.
Thank you, Sophie. Even the disk space is getting low. You made it.
Yeah, great.
And in the meantime, please, audience, put your questions in the question tab or raise the hand. There's a raising hand function in the control panel, so I can open your mic. But best is to be to do the questions tab, because then we can prevent feedback. And I have already some questions here. Yeah, very basic questions. Where can I find all those packages you talked about?
I provided some links, the blue links already on the slides, and I also added here a link collection at the second last slide in the presentation, where I added all the packages here. Those are the Git repositories, and I also added some additional information, like for instance, we work on a complete DMA documentation, which is also linked here.
And more detailed about the asset IDs question. Does asset IDs have to come from the blockchain, or can they, for instance, also be company internal identifiers?
Yeah, that was actually a question we also thought about a lot, because obviously our huge data archive already has some internal unique identifiers. And there are some kind of two answers to this question. The first one is, if you want to sell the resource, the asset IDs have to come from the blockchain. So in this case, yes, they have to come from there. For instance, in our case, we are not using only asset IDs from the blockchain, but also random ones, because if the resource is for free, so no license, no price is connected to the resource, the asset ID does not have to come from the blockchain. So depending what you want to do, a yes or a no to this question.
Okay, and then there's another question. Could these packages also be used if a data provider has no metadata server? So for example, if metadata is only stored in file headers?
Yes. As I said before, this CSW server component has to be replaced by any component as an external node is hosting. So everything that's needed in here and in here is the metadata. So for example, if you only have a folder per day where you put in all your XML files, just return the XML files from there. That's a solution for there. Or if you have your metadata only in the file headers, just write a routine which gets the metadata from this headers and return the metadata there in the easiest way, probably in a simple JSON file, and put in a mapping between this JSON file and the DMA-DCAT file into the metadata mapper. So if metadata is available, it does not matter how this metadata looks. These packages can be used with any kind of metadata. Just obviously, depending what you're using, you will have to make some adjustments.
And there's another question for the registration of the whole thing. The user can be set up in the user management.
Yes.
Yes. So this is the link. User management data marker DT register organization as an organization.
Yes. Regarding this point, I have to say I was not completely involved in the whole setup of the user management, so don't take my answers for completely granted. But for what I know, yes, go to the
Yes.
user management, set up your user, and also really important, register your client. So your services have to be registered there. Otherwise, if you try to connect via service, you can't connect to DMA components if they are not registered.
Yeah, so you have no token and the ID. Yeah. Okay. Yeah. Yes.
Maybe a point then.
Yeah.
The whole user management is also explained in more details in the documentation link I have on the very last slide. So maybe just have a look there. Maybe the questions can directly be answered there.
I think this is in general. So we are working very hard to get the documentation running, and this link collection of yours is very useful for that. And also, as a next step, as I said in the beginning, the portal integration is on the way to put all those modules a little bit closer together. And yeah, you will hear from us in the next months again. So at the latest in September, we have a presentation of the final version. And before that, you are very welcome, very welcome to ask questions, to do things, get in contact with us. So we are open for every interchange. And if I look at the participants list, I'll see new friends and old friends. Please stay in touch with the DMA. The project is it worth, I think. Yeah, these are my holy last words. Don't know if you have something to say, Sophie and Christoph, at the last, or should we close here?
Yeah, just if any questions come up, just send me a mail. I will be happy to answer them. And also, if you have any questions, if something is not running, if you try out the packages, just send me a mail. It's not perfect. I don't say it's perfect. So if something not runs, just send me a mail, please. And yes, that's would be from my side.
In the next hours, you find there's a blog entry on the Data Market AT website, a link to a video and a link to those slides, which include all those links to other resources and also Sophie's and Christoph's email address. Yes, that's it for today. Thank you for joining, and keep in touch with the DMA. There's always some news on the DMA website, datamarket.at. So thank you all. Bye-bye. Have a good day.
Bye.